Section 2 in Chapter 10 is called the liquid state, and it details the properties of liquids. This part should be a review if you took AP Biology. Properties of liquids. 1. They have low compressibility. They lack rigidity and have a high density when you compare them with gases. They also exhibit surface tension, which is the resistance of a liquid to increase its surface area. Importantly, for surface tension, liquids with larger intermolecular forces tend to have higher surface tensions. They also exhibit capillary action, which is the rising of a liquid in a narrow tube. There are two types: cohesive, and that is when you have intermolecular forces among the like molecules in a liquid, or adhesive forces, which is forces between the liquid molecules and something else, typically the container. If we're talking about capillary action, it is the container. Viscosity is the measure of a liquid's resistance to flow. With viscosity, the larger the intermolecular forces or molecular complexability, they tend to be more viscous. So the bigger it is or the more complex it is, the more resistant it will be to flow. So let's take a look here. We're looking at the convex meniscus formed by nonpolar liquid mercury. Which force is going to dominate in this glass tube, cohesive or adhesive? And you can look at the picture. You've got the glass tube, which is the yellow and red. Notably, you can see dipoles in that figure. And then the sort of white puffy things is the mercury. So which force is dominating? In this case, it's cohesive forces, and that's because the mercury is not interacting with the glass, it's interacting with itself. If we looked at the concave meniscus formed by polar water, again, this is concave, the previous slide was convex. If you look at the little blow up, you can see the water molecules are sort of lining up alongside the glass. So which force is going to be dominating here, cohesive or adhesive? In this case, it is adhesive. And that is all for section 2.